So a quick video on changing the midline of sine functions. What that means is, for example, adding a linear type of midline. By adding this extra term here, your sine function kind of moves up pretty much at a slope of 1/3, versus here where we add an exponential midline, the midline of the sine function moves up in an exponential way. And of course you can do this with a variety of functions. Let's go ahead and look at one example. Let's find an equation given some points. Let's say we know our equation looks like that, and we have the following table of points. So what we're going to do is we're going to find the equation by plugging these in and using substitution. So here we go. So I have our equation there, again in our table. First let's plug in this point, 0, 3. Again, 3 is the y, so I'm plugging it in here. And 0 is the x. Of course, pi fourths times 0 is 0. And then what's nice about this one is that both sine of 0 is 0, so the c disappears, and b to the 0 is 1, so we end up with just a equals 3, which is great because that was pretty easy finding one of the variables. So let's go ahead and plug in this second point here. Again, we'll plug in the y for 12.5, and x is 2. This time it's not quite so pretty, because when we plug in x equals 2, we get sine of pi halves, which is 1. So we do get plain old c. It makes it nicer, but it doesn't make it disappear. And then, of course, our b squared doesn't disappear either. So there's nothing we can do with this one yet. So let's go ahead and do our last point for 48. Okay, well, when we do that, again, something pretty happens, and honestly, we got lucky here. Sine of pi is going to be 0 again, and so we end up being able to solve for b. This is great. So we know that b is 2, and we know that this was our equation from the second point. When we go ahead and plug 2 in right there, we end up with c equals 0.5. And remember, this was our original equation. We found out that a was 3 right away, but then we weren't sure what b and c were, but we just found them. And so this is the answer.